All right, the first question we're going to work on is the 2013 free response problem called the gravel processing problem. And this is problem number 1 on the AP exam that year, and the first 2 problems are always calculator active, so we will be using the calculator to work through a lot of this problem. So let's read through this. On a certain work date, the rate in tons per hour at which the unprocessed gravel arrives at a gravel processing plant is modeled by G of T. Now remember that G of T is a rate in tons per hour. And this is 90 plus 45 cosine of T squared over 18. And T is measured in hours, and the given domain is 0 to 8. So at the beginning of the workday, which is where time equals 0, the plant has 500 tons of unprocessed gravel. That's our initial value. And then during the hours of operation from 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. So what you have here is G of T as the rate in, meaning the rate at which the gravel arrives, whereas the rate out is 100 tons per hour. So they then want you to find G prime of 5. So G prime of 5 we're going to get by differentiating G. Now remember that G is already a rate function. So when we find G prime of 5, we are taking a rate of a rate, and so our units are going to be, instead of tons per hour, it's going to be tons per hour squared. And we're going to work this on our calculator. So go to your TI-89, and I would go ahead and clear out A to Z, which clears out any stored values. And I would clear out, or I would actually I'd clear out everything out of my y equals as well. And then I would also, let's see, go home, and then I would do new problem to clear my screen. And I would start by typing in my problem, my G of T, 90 plus 45 cosine of T squared divided by 18. And I always hit enter, and I just make sure that it appears exactly as I typed it in. And remember, you actually want to compare this equation on the left, because on the right they typically work to simplify or write it in the way the calculator thinks about it. So I like to do on the left here 90 plus 45 cosine of T squared over 18. That is exactly what I meant to type in. Check here to be in radian mode. I am in radian mode, so I'm good. So G prime of 5, I'm going to go to F3 for calculus, and choice 1 is differentiate. And I'm going to grab the expression that I just typed in, and I'm going to put comma T, close parentheses, and that gives me the derivative with respect to T. And now what I want to do is evaluate this where T equals 5. So I'm going to go grab my derivative expression and hit enter to bring it into the main row here. And I'll use the such that key and then type in T equals 5. And I'm going to get, I have it on auto mode, so this is an exact answer. In order to switch this to a decimal, I'm going to grab it, go up 1, hit enter, and then before I hit enter again, while my cursor is still on this row, I'm going to hit green diamond, enter, and I get negative 24.587 or 0.588. So that is the answer to part A, negative 24.587 or 588 tons per hour squared. Now it asks us to interpret the answer in the context of the problem. So my interpretation is this: at time equals 5 hours, the rate at which gravel is arriving is decreasing, and that decreasing is because of this negative sign, at 24.587 tons per hour squared. So notice that the rate itself is decreasing, which gives us an acceleration units here. So part B says, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. Well, that means that we have to integrate the rate in, because the integral of G of T on the interval from 0 to 8, which is the hours of operation, will give us the total amount of gravel that has arrived. So we go back to our calculator, and notice that the very first thing I had done was type in the g of t equation on its own. I didn't use any calculus on it when I first typed it in because I wanted to have this equation typed in to make my life easier as I went through the problem. So what I want to do in a clear row is go to F3 and choose integrate and enter. Then you're going to scroll up until you get the g of t equation and hit enter. Now you've got the integral, and you say comma t to say integrate with respect to t, then comma 0, comma 8, close parentheses, and this creates the integral of g of t from 0 to 8. We'll give this a moment to think, and we get 825.551. So that is going to be in tons because we have tons per hour times the number of hours, the units of the integral. So 825.551 tons. Part 3 says, is the amount of unprocessed gravel at the plant increasing or decreasing at time equals 5? Show the work that leads to your answer. So this is where we are comparing rate in versus rate out. Our rate in is G, so we have G of 5, and then the rate out is a constant 100 tons per hour. So we need to take the expression G of 5 minus 100 and compare it to 0. We need to know whether this net rate is positive or negative. So once again, we go back to our calculator. We'll go up and, actually let me clear out this row. Then we will go up and grab the original G of t expression that we typed in, and we are going to evaluate it such that t equals 5. And I'm going to go ahead and pull this in to my main row and hit green diamond, enter, and I find out that the rate in at time equals 5 is 98.141. So this is 98.141 minus 100, which is very clearly less than 0 because we're subtracting out a greater number. And therefore, the amount of unprocessed gravel at the plant is decreasing at time equals 5 hours. And this is the work that leads to your answer. So you do need to write decreasing, and you've shown that this net rate is negative. All right, so part D is the part that deals with the candidates test. It says, what is the max amount of unprocessed gravel at the plant during the hours of operation on this workday? So the maximum amount is going to be driven by either a critical point or an end point. So what I need to do is first identify the candidates. So to identify the candidates, I need to set the derivative equal to 0. Well, the derivative in this case is going to be the rate in, g of t, minus the rate out of 100. And then we need to find where we have critical points on the interval from 0 to 8. So I recommend using your graphing screen, and I would go ahead and key in 90 plus 45 cosine of, you have to use x squared instead of t squared because we're in the graphing screen. So we have 90 plus 45 cosine of x squared minus 18 minus 100, because of course it's the net rate that you're finding the critical points for. For your window, you need to go x min is 0 and x max is 8 because that's your given domain. And we'll graph it and we'll see how many critical points we have. Okay, it looks like just one. So if I use F5 and I find the 0 of this function, my lower bound, let's see if I can see it. I think my lower bound, this is going up, my y values are going up, so I think I'm at my lower bound. And then I need to scroll to the right until I go to a negative y value. And here we are. And I can hit enter and it guesses for me. So my 0 is going to be 4.92348. So coming back over to this page, what I want to do is create a table of values. And remember that I have a time value, and then I'm going to have the amount of gravel. And the amount of gravel is actually going to be the integral of g of t minus 100 dt from time equals 0 to time equals x, which is whatever time we get to. So we have to have our critical point in here, which remember was 4.92348. Notice I put in more than 3 decimal places because we want to be as accurate as possible. And then our endpoints are at 0 and at 8. Now we know from the problem that at time equals 0, there were 500 tons of unprocessed gravel. So that's right here. At time equals 4.92348, we are going to have the initial value of 500 plus the integral of our rate in minus our rate out from 0 to 4.92348. And then for time equals 8, we have the initial value of 500 plus the integral from 0 to 8 of g of t minus 100 dt. So I need my calculator to evaluate these. I have, going back to my home screen, I'm going to take first the integral of the rate in function, which was the very first thing I typed in. See how useful it is that I had that typed in. And I need to open up another parentheses here because I want to have not just my rate in, but also subtracting out my rate out. And then comma, t, comma, 0, comma, and then the first one is 4.92348, close parentheses. And whatever I get here is actually the net change from today, and I need to add that to the initial value of 500. So I'm going to have 500 plus 135.376, which is 635.376, and of course that's in tons, but we'll deal with the units in a minute. Now I need to figure out how much gravel is left at the end of the workday. So all I have to do here is change my upper limit of integration to time equals 8. And then I hit enter and I wait for my calculator to resolve. And whatever number I get, I'll have to add to the 500 initial value. So I have 500 plus this 25 number, so it's 525.551. So the question was, what is the maximum amount of unprocessed gravel on this workday? And the maximum amount is between 500, my initial value, 635 or 525. So this 635.376 in tons will be the max amount. And it says justify your answer. Your justification is this table that shows all of your work.